So yesterday we multiplied binomial times a binomial, or we multiplied a binomial times a trinomial, right? And the day before that we multiplied a monomial times a binomial, or a monomial times a trinomial. Today we're going to multiply special cases. Special cases because we're multiplying the square of a binomial. So if we multiply a plus b squared, this means a plus b times a plus b. If we actually multiply using FOIL or the distributive property, we get that a squared plus ab plus ab plus b squared. If we combine like terms, we have a squared plus 2ab plus b squared. Why 2ab? Because the coefficients are 1 and 1 right here. Do you see how this is exactly the same thing as this? We need to work out x plus 7 squared. We can do two things. We can use the formula for the square of a binomial, or we can actually multiply it out using FOIL or the distributive property. So I'm going to use the square of a binomial. A plus b squared equals a squared plus 2ab plus b squared. That means that x would be a and 7 would be b. So a is equal to x and b is equal to 7. If I substitute in the equation, if I substitute a with x squared plus 2 times x times 7 plus 7 squared, x squared plus 14x plus 49. Now, I'm using the square of a binomial here. What if instead of substituting with the square of a binomial, I actually multiply x plus 7 times x plus 7? We could use the FOIL method or distributive property, the distribution method. And I would say x times x is x squared, x times 7 is 7x, 7 times x is 7x, and 7 times 7 is 49. I combine like terms, x squared plus 14x plus 49. You arrive to the same answer. Now if we try a minus b squared to see how this formula works out, we can say a minus b squared is equal to a minus b times a minus b. You can use the FOIL method that we learned yesterday. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ab again. And negative b times negative b is positive b squared. We can combine our like terms. A squared minus 2ab plus b squared. See how this is exactly the same thing as this. If we try to find 4k minus 3 squared, we can use the square of a binomial to find this. Say a minus b squared is equal to a squared minus 2ab plus b squared. In this case, 4k would be a and 3 would be b. So a is equal to 4k and b is equal to 3. If I substitute 4k squared minus 2 times 4k times 3 plus 3 squared. So 4 squared is 16k squared. 2 times 4, 8, and 8 times 3, 24k plus 3 squared. What if we work out the same problem using the FOIL or the distributive property, the distribution method? We'll distribute 4k to 4k and 3. Distribute negative 3 to 4k and negative 3 to negative 3. So 4k times 4k is 16k squared. Negative 3, 4k, I'm sorry, times negative 3 is negative 12k. Negative 3 times 4k is negative 12k. Negative 3 times negative 3, positive 9. If we combine the like terms, we end up with 16k squared minus 24k plus 9. Did we end up with the same answer either way? Yes. The difference of squares is of a plus b times a minus b is equal to a squared minus b squared. Now, if we actually use the FOIL method, or the distributive method, you could see that this is true. And a times a is a squared, a times negative b is negative ab, b times a, positive ab, and b times negative b is negative b squared. If we combine like terms, these like terms cancel out, and we end up with a squared minus b squared. I'm sorry. If we try an example, we could say we need to find t cubed minus 6 times t cubed plus 6. If we're using the formula for the distance of squares, for the difference of squares, a plus b times a minus b equals a squared minus b squared. So in this problem, this will be a, this will be b, a and b. So if a is equal to t cubed and b is equal to 6, we can substitute and say t cubed squared minus 6 squared, t to the 6 minus 36. Now we can also work out this problem using the FOIL method. We multiply t cubed times t cubed, t to the 6. When we multiply exponents with the same base, we add the exponent, plus 6 t cubed minus 6 t cubed minus 36. We combine our like terms. They cancel out. We end up with t to the 6th power minus 36. Did we get the same answer either way?
Yeah.